Okay, good morning all. So today class we will start the unit 3. So the title of the unit 3 is domain testing and paths. So in this domain testing, and paths we have two parts. First part is domain testing. Next we will discuss about the paths. Okay. So in the first part, domain testing, what are the topics that we have to learn is the domain testing. We have to learn about the what is a domain and what is a path, what is nice and ugly domains, domain testing, followed by the domains and interface testing, and domains and testing. Completely we will discuss about the domains. Okay. The first part we will discuss about the domains and how it is how the domain is tested and followed by the testing strategies. We will see in the third unit, first part. Again, we have the second part also. In the second part, we will concentrate about the paths. Okay. First part is about the domains and the second part is about the paths. First part is domain testing. First, we will discuss we will start the first topic called domains and paths. Okay. So the first topic is domain and paths. So first of all, we need to know what is a domain. So generally we have a mathematical definition of domain is nothing but a set of values of a variables. A variables which contains a set of values that is called the domains. And this domain is also called as boundaries. Okay. So why it is called as boundaries? Generally the technical word or generally the natural word of the domain that we use in real-time world is domain. Which domain you are doing, which domain you are learning. So the domain which I am referring is computer networks, or the domain which I am working on is some on computers. So we will mention some domain that is nothing but the specification. That is nothing but the domain, nothing but we will specifically working on that particular domain is called the domain. So when you're performing, when you are doing work on the computer networks domain, you will work on the computer networks only. You does not go on to the next topics of the next specialization. That means a domain will have some boundaries. So that according to that boundaries only, you will do some work on that particular domain. Like that, here domain is also some set of values. The set of is a domain is a set of values of a variables or a variables of a function. This domain is also called as boundaries to that variable. Okay. When you are doing when you are taking a domain, so you are taking a domain path. This domain path will have a variables which will have some boundaries. That is called the domain. Okay. So what is a domain? Domain is a set of possible values of a variables or variables of a function. Okay. Domain can be specified directly and predefined by their boundaries. Generally, a variable is defined. For example, a variable should contain this number set of values. To which category the set of values considered means based upon the domain. So that is called domain. Okay, so domain is nothing but a boundary of that variable. It specifies which value has to be inserted into that variable. So domain can be specified directly on and or predefined domains. Already we will have a boundaries that are already predefined. We can use that predefined boundaries. Okay. A single domain may consist of one or more boundaries. For example, you are taking a single domain. It contains one boundary or second boundary. Boundary is nothing but here predicts, means nothing, conditions. Okay. Based upon that conditions only, that values has to be executed. The set of values has to be analysis. Okay, boundary is nothing but the condition to that set of values on that particular variable. That is called the domain. So domain is a single domain may consist of one or more boundaries, and that means it can contain one condition or more than one conditions. Based upon that conditions only, that set of values will be executed. Okay. Domain is a set of possible values of variables or variables of a function. Okay. Then what is domain testing? So domain testing is nothing but you are doing testing on the domain. You are doing testing on that set of values. Okay. You are performing some different types of testing on that set of values is called domain testing. Okay. So when you're performing a domain testing with that values, what it will produce means it will classify that uh, it is doing correctly or not. That is called domain test. When you are performing a domain testing on a set of input values, it will finally decide that it is doing correctly or not. That is called domain testing, performing correctly or not. See, domain testing attempts to determine what it determines, whether the classification is correct or not. It determines, finally, you determines that whatever the classification you are doing on that particular values, input values, so that is done correctly or not is called domain testing. Okay. So domain testing can be done on two different ways. One, domain testing can be done on specification, or domain testing can be done on implementations. What is specification? What is implementations? Specifications is nothing but the requirements. Whatever the input values that you are doing, that is called specifications, requirements. That is called the specifications. Or you are performing domain testing on implementation, calculation. So that is called the implementation. So domain testing can be done on the specifications or implementation. When you are doing domain testing on the specification, then it is called a functional testing. You are performing functional testing. Or you doing domain testing on a implementation, that is you are performing structural test techniques. Okay. So domain testing can be done in two ways, or domain testing can be based on specification or implementation information. So whatever information you are producing for the testing, whatever information you are giving to the domains based upon domain testing, based upon that testing on that the input values only, it will do the testing process. You're giving the input values based upon the specification, it does the functional testing. So you do giving implementation information means it does the structural testing. So domain testing performs the specific functional testing or structural testing. Okay, this is about domain testing. Domain is nothing but a set of values to a variable which can perform domain testing on that set of values based upon the boundaries. According to the boundaries only, according to the restrictions only, we will perform the testings. According to the restrictions is nothing but predictions. Predictions is nothing but conditions. That based upon the conditions only, it will check that the values or the input values which is given to a variables are performing correctly or not. That is called domain. So what is a path means? Path is nothing but the path which you are taken for execution is called the path. Okay, which taken for domain testing, that is called the path. So next one, this is the model representation how a domain testing has to be performed. So in this, so in domain testing, generally we will give the main agenda of domain testing is it takes a set of values and do classification. Classification is nothing but performing testing and do and checks which case is satisfied. If this satisfied, then it gives the that related output. That is the main method of domain testing. So it takes multiple input values and produce output according to the according to the input values based upon the different classifiers. Okay. So see, this is the figure that represents domain testing. So see here, it takes input value, finally it gives the output. In between input and output, we will have classify and some different cases. These classifications is done based on different cases. Okay. So if which case is satisfied, that case will be executed, performed, and output will be produced. Okay. See this. So routine is nothing but a path must classify the input and set it moves from the right path. So if the what is the purpose of classify means it will this classifier will check that a path which is taken or the input values which you are taken is going on the correct way or not. That is the main purpose of classify. Okay, the routine must classify the input and set it moving on the right path or not. It is working on the right path or not. It will checked by the classifier. Okay, if you are giving an invalid input, with a special processing called reject. Sorry, it is not project. Reject will be done. Okay. So you are giving the input values that which are not related to that your condition. So generally, classify how it decide that it is working on a correct path or not according to the statement which you are given, according to the path which you are taken. It will check according to that statement and will check whether you are giving the correct input or not. Okay, if you are not giving a correct input to related to that related statements, then uh, a new and then a another process, special processing case will be executed called reject. Okay, that is called reject, not project. A reject will be done. In domain testing, we focus on classification accepts of routine rather than calibration. So it will generally in domain testing it will do classification rather than calibration. How it is calculated is not important here. How it is classifying, how it is passing, it is passing on the right path or not. How it is working, that is important. Not about the classification. Okay, how not about the calculation. That is the main agenda of the domain testing. Next one. Structural testing is not needed for this model. Only consistent specification of input values are needed. So the input values what we have taken is it does not need any structural specification. Structural knowledge is not necessary. Only this model is only takes the input values. Based upon the input values what you are giving to the classify, based upon that input values only it will do the classifications. Okay, if you give set wrong input values, the rejection will be done. Okay, so the whole model will represent about the input values, finally does the classifications and check which cases are working, which cases are sets for this classification, and finally according to the right classification it gives the output. Only that is the main process of domain testing. So the main agenda of domain testing is set of input values, not about the structural knowledge. How the structure is represented is not important. The whatever the input is given is important. That is the model of the that is the model of the domain testing. Okay, so that is the model. So now we have to see what is a domain, what is a path, and what is a predicate. So domain, I have already seen, domain is nothing but a input values or set of input values to a variable. Domain testing predicates are related to the input value. Domain testing is generally done on the input values which is given to the variable that was predicated. Predicates, that means predicates is nothing but a condition. Based upon the condition are related to the input variables. Okay, so generally domain has at least one path. So when you are performing a domain testing, so domain means compulsory domain, a set of values should contain one path. At least one path has to be taken. Okay, for every domain there is at least one path. For example, you are taking variable x as a domain, it contains a set of values, compulsory it has one path. It has to be executed in one path. That is, for example, x is equal to x plus 1. That is a path. But compulsory the x variable should contain one path or more than one path. At least one path must be taken for a domain. Domain is nothing but a variable. Okay. For that variable, you are performing the domain testing according to the path, according to the statement that you have taken. Next, there may be more than one path if they are disconnected paths. So if the path is not connected, then we can have the multiple paths. That paths are called the disconnected path. Okay. So if there is multiple paths, means they are called the disconnected path. Okay. So generally domain will define. Generally, a particular domain is defined based upon the boundaries only. So whatever the boundaries is represented to that particular domain, that domain will be defined. Okay, boundaries are very important. According to that boundaries only, that variable, that set of values will be executed. Boundary is nothing but a condition. So according to that conditions only, the set of values will be executed. So boundary can be mentioned as predicate that specifies which domain belongs to the path and which domain does not belongs to the path. According to the conditions only, according to the predicate only, according to the boundaries only, we can decide which domain belongs to which path, which domain belongs to another path. Okay, that is called the boundaries. So here we will see a small example. Okay. If x greater than 0, then alpha else beta. If the x value is greater than 0, then we'll go to the alpha process. So that's why here mentioned see different cases. Different cases means alpha case, beta case, or other case, remaining cases. According to the classification, it goes to that case and finally produce the output. Okay, based upon the inputs which are taken to a domain called a x. If x greater than 0, then alpha else beta. Here, when the numbers greater than 0 belongs to alpha process, then we go for alpha process. So whatever alpha process will has to be executed, it will be executed based upon the x value. So and domain, if the number is 0, if the number is belongs to 0 and smaller number, if the number is smaller than 0, belongs to beta domain. Okay, the values are linked with the predicate to execute the path. According to the condition only, the path will be executed. That is called the, that is a small example of the domain. So domain, how it is checked according to the boundaries and how to which path it will go for execution. Okay, domains are defined by many boundary statements, that is many predicates. Here we have seen only one predicate called x greater than 0. We can go for the multiple predicates, compound predicates, that is called the compound predicates. That means more than two predicates, two based upon two conditions also, the path will be decided. For example, x greater than 0 and we are using a logical AND operator followed by x less than 0. You need to check these two conditions. These are called compound predicates. So a boundary can have a single predicate or more than one predicates. So next, this is a domain closure. So domain closure, the domain boundary is domain closure is nothing but a, see this diagram here, this black color dots are called the domains. That means boundaries. So these boundaries sometimes can be open and sometimes can be closed based upon the boundaries that you are defined. Okay, the D1, D2, D3 or domain in a single line. This single line is called the one dimensional. The domains can be a one dimensional, two dimensional, three dimensional. Okay. So what is a domain closure means? Domain boundary is closed. When this domain boundaries are closed, see here two dots are represented in whole black color dots. That means closed with respect to the, it will close with respect to the, this domain closure. So whatever the points that is closed, give the differentiation between the other domain to the other domain. D1 domain and D2 domain is not interfering with the D1 to D2. X is not interfering with Y is not interfering. Yes, they are a separation called the boundaries. If the boundary is closed, D1 does not interfere into D2, D2 does not interfere into the D1. Okay. If it is not closed, then interfere will be, overlap will be done. Okay. So a domain boundary is closed. When it will be closed with respect to the domains, if the points on the boundary belongs to the that domain, according to the boundary of that domain. For example, D2 is a domain, it will have some boundaries. Based upon that boundaries only, you need to close that boundaries. Okay, you need to close that points. So D2 have some boundaries. Based upon these boundaries, you will be closing that maximum and minimum points. Okay, that is called closed. If what is meant by open means, open is nothing but you are not producing correct boundaries to that particular domain. It will goes open if the boundary points belongs to some other domain. So for example, this maximum boundary point relates to the D domain 3. So then it will be open. Okay. So minimum and maximum 2 points are related to D2 boundary only, then it will be in closed state. So minimum is one boundary related to D2, maximum is another boundary related to D3, domain D3 means one will be closed, one will be open. See, domain boundary point belongs to some other domain. So the boundary points are related, not the same domain. So it is related to another domain, then boundary is said to be open. Okay, so here, see this here, we have taken the three situations for one dimensional domain. So the single line is represented as a one dimensional domain. That means domain D1 will take only one variable, D2 will take only one variable, D3 will be take one variable. That means the computation or predication or classifications are all done on a single variable. That is called one dimensional. For example, if D2 is taking X and Y, then it is called two dimensional variable. Here we are doing one-dimensional domain, that is called domain defined over one input variable called x. That is called one-dimensional representation. Here, minimum and maximum are the boundaries of D2. So here, both sides are closed. That means D2 is closed with the boundary min point and max point. That means these two boundaries related to only D2 only. So the domain which is the domain boundary is called as but the domain boundary is closed means it has to be closed with the same domain boundaries, same domain conditions only. Okay, so next one is one side open, one side closed, one side open. That means when the one point will be open, when the boundary is said to be open with some other domain, this domain is not related to the D2, it's related to D3, this point, this boundary point. That's why this is open. This minimum point is only related to D2 boundary domain, D2 domain boundary. That's why it is closed and it is open. So two points are open means D2 does not close with their own boundaries. That's why both are open. Okay, that there are three cases or three situations that will arise when domain closure will be done. One is both sides will close, one side will open, two sides will be open. Both sides will be closed means domain boundary is closed with respect of to the same domain points. Same domain points based according to the same domain points. Okay, is it clear? These are the three ways to represent the domain closure, and these domain closure is represented in one dimensional domain. Next point we will have to discuss about how many dimensions of domain representations can be done. Okay, so here the next one is domain dimensionality. So domain dimensionality means the dimension what you are taken is represented called the domain dimensionality. So every input variable adds one dimension in that domain. So generally, if you are using one variable, then it is called they call one variable dimension. When you are using two variables, then it is called two variable dimension. And when you are using three variables, then it is called three variable dimensionality. Okay, so domain dimensionality is nothing but every input variable adds one dimension to the domain. So when one variable is added, another dimension is added. When another variable is added, another dimension is added. 2-dimension, 3-dimension, 4-dimension, like that. So here we will have three types. One is a number line. Number line is nothing but what you have seen in the previous example. This is called number line. So the domain D1 or domain D2 or domain 3 will in the same line, but each domain will takes input values of only one variable X or Y, only one variable. Okay, that is called the number line. If you are taking two variables defined, you are defined two variables and you are accessing the calculation or you doing process on these two variables, then it is called planar domain. Okay, when you are performing on three variables or you are defining three variables, then it's called solid domain. These are the three representation of domain dimension. Okay, so up to now we have discussed what is a domain, how the path is defined, how the domain testing has to be done, and with the model of the domain. And we have seen a small example of the domain closure. What are the different types of domains can be represented? Okay, the next one is bug assumptions. So in this domain testing also we will bugs will be erases. In which cases these bugs will be erases. Okay, bugs assumptions means the domain testing process is okay, but the domain definition is wrong. Obviously, but when the bug will be erases, when the process is not working correctly or the input values which you have taken is not correctly, these are all comes under the bug assumptions. Okay, when the domain test is not performing correctly, if the domain test is okay, then there is no bugs, but the domain test is not okay means the bugs will be erased. That is the first point. So next one is an incorrect implementation on the domain. You are not performing correct implementation. There, the prediction is different. You are performing on the different prediction. Okay, implementation is done on implementation is done incorrectly. Then the domains it is not done according to the boundaries. So according to the condition only, the implementation has to be done. Okay, according to x greater than 0 only, you need to check that particular variable. But you are not checking, you are not taking x greater than 0, you are performing an x less than 0 boundary means it is an incorrect implementation. Okay, An incorrect implemented domain means the boundaries are wrong. You are taking the boundaries, wrong boundaries. I think at this point, everyone has a point on what is a boundary, what is a domain, what is a domain testing. So boundaries is nothing but prediction. This point has to be recognized when you're doing a domain testing. So okay, an incorrectly implemented domain means the boundaries are wrong. You're performing on the wrong boundaries, then implementation will be performed wrong, which may lead to the wrong graph. Long graph will be represented and bug will be arises. Okay. So these all bugs are called as domain bugs, domain errors, domain errors. These are different errors that will produce in the domain produce in the, these are the different bugs will produce when you are performing the domain testing. The errors that are produced in the domain testing are domain errors. They are called as domain errors. So these are the different bugs that will arise, or the bugs will be arised when you're performing domain testing. What are the bugs? What will be the bugs that will produce? One is domain zero representation. Domain zero representation means, sorry, double zero representation. Double zero representation means the zero what you are representing on that bug will be arises. Okay, generally a zero does not have a positive or negative value. It does not mention a zero with the positive zero or negative zero. This will comes under a bug here. So generally a computer will does not have a positive or negative zero. Boundary errors of negative zero are found. Generally, according to the negative zero only, the bug will be erased. That bug is called the bug double zero representation. Okay, when you are representing a zero or the negative zero, then the bug will be erased. That is the first bug assumption. Next one is contradictory domains. So contradictory domain specifies the two distinct domains overlap. For example, if there is no closures from one domain to the another domain means there is no, generally the overlap of the boundaries will be done. So this is again a bug. This is again an error. That type of overlapping of boundaries is called the contradictory domains. Okay. So when contradictory is performed on particular domain, the domain cannot understand which boundary, which predict has to be executed. So next one, ambiguous domain. So ambiguous domain is nothing but the incomplete or missing domains, not specifying the values, which may result no values, also called as holes in the domains. First of all, these all classifications or these all predications are done on the input values which were given to a domain. Okay. So you are not giving the values and you are missing some domain values, then ambiguous confusion will be arises to the domains on which value the prediction has to be done. The boundaries has to be implemented is a problem that will be arise when you are missing some values to the domains. That missing values or that no values are called as whole values. They are represented whole values, whole in the mind, called as holes. Next one, over specified domains. A domain can be overloaded with so many conditions where the domain path becomes an achieved. Generally, so we can take compound predictions. That means not only a single boundary can be taken. X greater than 0 is a one predict. We can take another predict with the combination of x0, x greater than 0. We can go for n x less than 0 or n x equal to x plus a. These or predications can also be applied to that particular domain. But if you're taking multiple, we are taking so many overloaded conditions, then the domain path cannot be achieved. So the domain cannot understand which path has to be executed. So the path will not be becomes an achievable. That is called over specified domain. So we're specifying overly. Okay, next means faulty logic. So you are taking the logic, not taking the correct logic. That is called faulty logic. Compound predicts are subject to faulty logic transformation and improper simplification. That is called, you are not specifying the correct logic. That is called the faulty logic. Generally, these faulty logic are subjected to compound predicates. Multiple predicates, when you're performing on multiple predicates, this faulty logic will be arises. Next, closure reversal. Okay, this is a common bug. The programmer choose to implement the logic incorrectly. So if when you are executing or when you are performing a predicate on a particular variable, it's not correctly choosing that predicate, then this particular closure reversal will be erased. See here, for example, if the predicate is x greater than 0, it is incorrectly negated as x less than 0. Okay, generally the program wants to do the predicate as x greater than 0, but they are mentioned it x less than 0. That is called incorrectly negated predication. So this type of predication is called nothing but closure reversal. So the path will be changed. The execution path will be changed. Okay. The implementation process will be changed to x less than 0 instead of x greater than 0. That is the bug will arise when this improper representation of predicates. Okay. These are the different bug assumptions. Okay, one is double zero representation, contradictory domains, ambiguous domains, overspecified domains, faulty logic, closure, reversal. These are the different bugs or errors that will produce when you are performing some domain testing. Okay, the next one is restrictions to domain testing. So the restrictions is also called as disadvantages. So what are the disadvantages that will be produced when you are performing a domain testing? So these are the following disadvantages that we perform domain testing. That means domain testing is not good for finding the bugs for which outcomes is correct for wrong reasons. So you're performing a wrong reasons and producing a it wants to produce an outcome that is considered as correct output. That is the main disadvantage. See, the domain testing is not good for finding the bugs for which the outcome is correct for wrong reason. So when you're performing on the wrong reason that and the outcomes is correct, that is a disadvantage. So you're taking reason is one, but the output is another. That is the main disadvantage of domain testing. So next, domain testing becomes weak when you're performing on the binary outcomes. So binary outcomes are nothing but which have the two values, or 0 or 1, 2 or false. These are the binary values. When performing domain testing on the binary values, it performs very weakly than the normal values. Okay. Slow and the loops are representation of loops in domain testing also problematic. The loops are also problematic for domain testing. And another disadvantage is when you are defining a predicate called AB plus DEF defines two subdomains. Here ABC is one subdomain, DEF is another subdomain. Domains which is defined by a predicate ABC plus DEF defines two subdomains, one corresponding with ABC and other with DE. But initially you are defining it as ABC plus DEF as one path only, but it will take us two different domains, ABC as one and DEF as another domain. That is also a disadvantage, but it has to execute as one domain only, but it will execute in two domain ways. Okay. Next one is problem arises with simple domain boundaries and compound predicates also. When you the problem arises when you are allowing the predicates, the boundaries which you are giving to a variable is also a problem. When you are giving a simple boundaries is normal. When you're giving complicated boundaries, like see this like this, x greater than 0 and x less than 0 can be executed because it is performing on the single variable only. When you are giving x equal to 0 and x greater than y greater than 7 and y greater, you are performing on two variables. This is also complicated predicate, but it's a little bit difficult. This also results in wrong results. Okay. So by using compound predicate boundaries produces wrong results. It is very little bit complicated. Okay, these are the disadvantages that will generate when you are doing domain testing. Okay, so up to this we have completed the first part called domains and path. From the in the next class we will see the next concept called nice and ugly domains and domain testings. Okay, is it clear everyone? Okay, thank you. We will continue in the next class. Okay.